So, what do we know?
I'll zoom in on your board.
First test we did was just to unplug all the O2s and test them. Rich, lean, if they respond. So,
Now, are they O2 sensors or are they hydrocarbon sensors?
clean air sensors, whatever you want to call them. These markers suck. No wonder they're repackaged.
Yeah.
O2s. Let's say all 4 sensors respond. Okay. This is unplugged.
Yep.
So this direct voltage measurement.
Yeah. Essentially bench testing, I guess.
Yeah.
In car bench.
Exactly.
Yep. So 4 good sensors.
And also we'll mention the heaters
All having continuity.
have continuity.
Okay.
Okay. Now, second observation. When we plug the sensors in, right, they all showed normal oxygen sensor activity. I mean, on our lab scope. We're not talking about scan data yet.
Yeah, this is all lab
real,
scope data.
real voltages.
Yeah, real data.
Real voltages. They were all okay except for bank 1, sensor 1, which showed a negative voltage ranging from -6.5 to -10 volts.
Yeah, that depends. One time it was -6, one time it was -9, one time it was -10.
Yeah.
So
it's always
that's
negative.
right.
It's just yeah.
Yeah, and that's
outrageous.
plugged in KO
So,
ER. Yeah.
to
Yeah.
key on engine run. O2 volts are reasonable, right?
Yeah, yeah.
And they responded to lean and rich.
Correct.
Went up and down.
Yeah. No difference other than bank 1, sensor 1.
Reasonable. Except bank 1, sensor 1, where the voltage, how about, check this out, voltage bank 1, sensor 1, and the range was,
-6.5, roughly.
yeah. So range was -6.5 volts. So voltage bank 1, sensor 1 was between, is it less than, well, okay, reverse that. Since we're doing negative numbers, it was actually less than -6.5, but greater than -10 volts, right? So that's our observation there. Completely, oh, I don't know what to make of that yet.
Yeah.
That's real voltage at the sensor.
I don't have an assessment, so.
But we can't say it's not coming from the sensor.
Correct.
Right? So
and remember,
okay.
Unplugged, it didn't appear to be coming from the signal wire. At least it wasn't being displayed on the scan tool. But that's a whole other thing. Remember when we unplugged it?
Yeah.
You would think if this
was coming from
the computer,
yeah,
it would be displayed unplugged, correct? But remember, even plugged in, the thing was showing 5 volts. So it's
You
whack.
mean on scan data or on scope?
scan
on scan data.
Yeah,
Okay,
so, but yeah, anyhow. I'm
so
still
we'll look into that. 3, scan data. What do we see on scan data?
I would summarize scan data as 3 of the oxygen sensors are flatline lean. Just, the voltage count is redundant. I mean, it's like 0.02, so.
3 O2s.
Lean, yeah,
Lean.
just as a summary. And,
Flat line.
yep, and then you go back to your troublemaker sensor, your bank 1, sensor 1.
Except bank 1, sensor 1.
On factory data was 5 volts.
Yep.
And then OBD2 data.
Okay, so that's another variable here. OEM versus OBD2. So we go to OEM is around 5 volts, and then OBD2 is around 1.275.
Yeah, that's right.
And it got there not right away, but it kind of gradually after we started the car.
Well, yeah. Do you remember? Wasn't it back in the beginning when we first plugged it in? It rose and rose and rose and rose, and then it was like bam, pegged out at like 5. Did something like that. I remember I'd have to watch back to the video, but yeah, it had a similar response. But
yeah. All right. So I guess we can talk and theorize all day long here.
Sure.
But I think at this point, we need to check the signals at the computer to see if we're getting the signals from the sensor to the computer, and why, what could be the reason for the scan data not reporting the real voltages. So,
regardless if it is -9 or if it is 800 millivolts, it's not reporting anything what we're seeing, regardless of what the actual voltage is. So that's, I say, back to the wiring diagram, find the pins, probe them at the PCM, see, because this wiring harness is a mess. Well, the little bit we can see, it's yanked out, it's pulled, it's cut, it's, it's obviously been played with. So, see if the data is making it to the PCM. It's the most reasonable.
So, wiring diagrams, right?
Correct. Wiring diagrams, awesome.
Let's take a look.
Yep. Okay, so here's one of the awesome problems that I love about Mitchell. If any of you guys use Mitchell on Demand or any rewritten wiring diagrams, you probably have the same dilemma that I do. Is we look this up, so we put it in 04 Mitsubishi Galant 24 ES, that's what this is, put it in by VIN, and the wiring diagram does not match the car because I went to O2 sensor data, and the colors displayed here are not the same colors that's on his car. So Ivan went out to get his laptop. He's going to check on all data to see. This is not uncommon. It happens so much it's actually depressing. I was in the middle of, I just thought this was going to go real quick, so I poked here on, this is BBB. I'll put a link to this. They have free wiring diagrams, free online wiring diagrams. So I'm going to let this load up. I'm going to compare these ones. I think they were just trying to flick back and forth here, just trying to slow this down. Let me get to the O2 sensors. O2. Okay, so these are showing red, brown, white, and black. That's not what we have. So there's like a zillion variables here. These cars can come with federal emissions, California emissions, Canadian emissions, and I don't know if there's different wiring diagrams. Ivan's going to look on, so because these are saying the 04. I'm not going to do it on camera. I'm going to poke up and down a couple years, see if I can find something that matches. Let me see what, you got yours up?
Yeah.
What do you,
So this is for an 04 Galant.
Yeah.
This is on all data here.
Okay.
And
what do you show for oxygen sensor colors?
So let's see.
See, yours look like the OE ones on
BBB.
On BBB.
So I know all data uses OE diagrams.
Yeah, Mitchell loves the rewritten ones, which are never right.
Anytime someone rewrites something, there's bound to be more mistakes.
Yeah.
OEM ones aren't perfect by any means. They forget stuff too.
Or either that, or they don't, upload, like California. This vehicle's California emissions. Just what do you got for colors? You got red, brown, white, and black.
White and black, yep.
And our O2 sensor wires, and that's for the left side. And you can see ours, regardless of the condition, are nothing like that. We've got like a red with white, a violet, a pink, a white with black. These all have trace colors. All right, well, I am going to, why don't you poke up a couple years on yours? Have you seen wrong wiring diagrams?
Oh yeah.
Have you run into it? So
Sure.
I hate Mitchell because this always happens. And now, but we've got an online chat system, so I'm gonna chat up whoever picks up on the other line, ask them if they can look in the factory data for us on the Mitsubishi website, because that's one of the services they provide, and see if they can email me some wiring diagrams. It's probably gonna take a half hour or so. In the meantime, I'm gonna look to see if we can find one. So a lot of times with variables, I'll go up or down a year and see if I can find one to match. Yep. So shut the camera off, we're gonna do some poking and see what we find. I'll email Mitchell or see if we can maybe get a results some sort. So, anyhow. Okay, we're back in action. We got a wiring diagram that matches. I got this off. Yeah, finally. Did a lot of poking, and I did email or send a message to Mitchell. They're going to be checking factory data for us, which is great, but it takes time. printed this off from BBB's website. I'll leave a link to their website. Ivan showed that to me, actually. I've never used it. I always use Mitchell and have to call them to get them to fax me the OEM ones or email them to me. It's always a hassle because the reprinted diagrams are always crap, 9 out of 10 times. And then they send us factory ones and we're good. But what's weird, this coincided with his all data, but in order to get it to match the colors on the car, I had to get it for an 06. The car's an 04, we double checked the VIN number.
The emissions label
here.
Yeah,
check the emissions label, which this is California emissions.
So we're thinking maybe for the 04 they only had federal listed on BBB and all data, but newer ones, maybe California's the same as federal, so maybe. 06. We see that the colors match in the 06.
Correct.
So we're gonna for now assume that that is the whatever California emissions 04.
Yeah, possibly. Well, the colors match on the O2 sensors. It appears from just a quick glance. It matched on. We took the computer here. We took the cover off the computer. We tipped it up so we could see the colors to see, well, is the O2 just matching or is the PCM matching? So the PCM seems to match. The O2's match. So we're just going to go with one that has the right colors instead of trying to do it by connector number in different colors. This is just easier. So just quickly, we'll try to show you the wire diagram each time. We went through and just labeled, bank 2 sensor 1, bank 1 sensor 1, and so on and so forth. So and then this here is the PCM. These are the pinouts here. Their connectors are labeled kind of funny. You got connector B22, B23. Which it gives us our pinout chart down here for those. So we're going to make sure everything here matches, make sure our wiring matches, and we're going to just highlight the wires for you as we test them. We're going to check them at the PCM, is that right? That's the easiest way.
We'll just jot them down.
Yeah, and we'll jot them down. So go ahead, Ivan, and highlight. We'll start wherever you like.
Well, let's do an upstream that is not too weird. So bank 1 sensor 1 is our odd man out.
That's our weirdo.
Yeah, so
that could be the special clean air one that we know nothing about.
So let's start with bank 1 sensor 2. It's on the right side, meaning the passenger side.
Always as you're sitting in the seat.
Yep. So for now, the heaters, we could do later if we have a problem with them, but we just want to check the integrity of the signal and the signal circuit.
Yeah, the heaters we don't care about because we're getting a signal.
Right. Yeah.
They're heating up on their own. They're taking longer, but.
So, here's the sensing circuit, and there's your ground. It's a sensor ground, and the symbol here is actually a little weird, and we have to look up what that means. What is that? A fork or a brake?
That is what I call a miniature broom. It's a miniature broom. It's not your typical grounding signal, I guess, for me, for what I thought. But what did we find when we looked that up?
Yeah, and. Compared to that one, that's your regular Christmas tree signal.
Yeah, so that's what we would typically think as a regular ground or earth ground.
Yeah. But for the inside the PCM, we have to be careful. It might be a bias voltage. Variables.
You never know.
But we looked it up. It just says ground inside control module.
Yeah, it was an internal control module ground.
It's just a ground.
So it's not
should be plain ground.
Yeah.
So let's start there. We'll back probe both wires here since we want to check the whole circuit. We could just ground down the battery, but then we would be kind of ignoring the ground here,
PCM
right?
Ground, So at least we'll see what's feeding to the PCM.
Yep. So let's.
And what are our wire colors there? We have yellow, and L on this diagram means blue. So
yellow and blue at the PCM, and our voltmeter is just going to be 2 leads hooked up. Nothing fancy.
Yep, and we're going in connector B22 for both of those, it looks like.
Pin 106.
And pin 97.
And 97,
Yep. Okay, so let's get hooked up so you guys know what we're doing and see what we see.
All right, so again, we're showing bank 1 sensor 2 side by side here. The actual voltage at the PCM with these 2 pins. And the scan data for that sensor. So we just want to see what the the actual signal is, and if the scan data is reporting what it should.
Sure, it might take a minute for it to warm up.
So this will tell us if our wiring is bad or if we suspect the PCM, right, Eric?
That's what I would assume. Yeah, I mean it's what it's displaying versus what it's receiving. Okay, so it's starting to.
This is the actual voltage at the computer, and you can see it's, you know,
Getting up there almost.
getting up there. And we'll do some things to change it, you know, the vacuum leak, maybe unplug it.
Yeah, say unplug it, make sure we're pinned in the right wires.
Yeah.
What's our scan data displaying? 0.020.
Like 40 millivolts, so it's still peg lean.
Same thing it was, but it's
Yeah.
actually at the PCM right now is
Yeah.
displaying almost 1 volt.
Yeah. So it looks like, at least for this sensor, the wiring is sound from the sensor to the PCM.
Yeah, let me unplug it. Okay, I'm unplugging the O2 sensor. That's what you'd expect. I'm gonna plug it back in.
Yeah. And the vacuum leak?
Yeah, go ahead and make a vacuum leak. That responded very quickly for a downstream.
This is a downstream sensor too.
Yeah, that's what I'm saying. It responded quite quickly, but the factory data still is stuck. This is in generic, correct? Your generic mode.
Yeah, we're in OBD2 right now since it did give us more data than OEM.
Okay. Well, you want to write down these results and move on to the next sensor?
Yep. So let's do this for each one.
Okay. I'm going to shut it off while we write it down and we repin it.
All right. Now we're going to move on to the next one on the diagram here. Doesn't matter. Bank 2, sensor 2. So these are the signal and return wires. Pin 96 and 105 on the same B22 connector, which is over here. So 96 and 105. So I guess just the next 2 wires over.
Oh, okay.
So that makes it easy.
So we'll get them. Which sensor was that again? That was Bank.
Bank 2, sensor 2.
Okay, so another downstream.
Another downstream.
Then we'll pull up the data and we'll turn the camera on.
Yep.
Okay, Ivan's got them all probed. I set the scope up. So we're Bank 2, sensor 2. So this is the other downstream. Let me go ahead and start the car up here. Heat up a little bit. That first one that we did, man, for being a downstream, that thing heated up quick.
The heater worked, I guess.
Oh, that's right. Yeah, they're plugged in. I forgot about that. Yeah.
Yeah. Because last time we had to rev it to heat it up.
Yeah, this one's starting to come up slowly there.
Yep.
And so we're creeping up on a half a volt. Scan data is saying 100 millivolts, 120. The actual voltage is almost 800.
Get our live reading right there.
Okay, so you got what your live reading is
0.7.
700 and climbing. Actual reading is
0.16, 0.18.
so it's go ahead and well here I'll unplug it real quick.
Yep.
Here, plug it, we lose it.
So that did drop right there to 0. We're gonna plug it.
It'll recognize the 0.
Yep.
Comes up to 200, comes back alive. Go ahead.
About how about a vacuum leak?
Yeah, go ahead and crack a vacuum leak. Okay, so that responded. Did the OE to respond to that? Do that again. I'm gonna zoom in on it. It responded, but the scaling is off.
Yeah, so it's hitting a max of, well, I guess there's a max, about 200 millivolts. So I'd still say it's peg leaning, but it's actually showing more response than the previous one.
Okay. And then, but our actual sensor is working.
Yeah, the signal is getting to the computer. It's at 0.9 right now, so it should be peg rich, but it's nowhere near that on the actual, or on the scan data.
Okay, so with this, just those 2 tests. Oh, hang on, somebody's knocking on the window.
All right, so we've checked both both downstream sensors, and the wiring integrity checks out fine. The PCM scan data does not go above about 200 millivolts, so he's peg lean.
Yeah, on that one.
Usually hanging out around there. And then, but on the actual signal is getting to the PCM just fine. We're seeing rich, lean changes.
Same thing we were seeing at the
same
PCM.
with the sensors. Okay, so let's check the upstreams now. Bank 2, sensor 1. So this is our signal circuit.
What colors we got there?
Now these are on different connectors. We got a white, blue, and a yellow blue.
All right, so we'll go find those. We'll plug
Yep.
into them and do the same test.
Yeah, see that.
And pull up the data. Okay, I'm going to go ahead and start it. And this is Bank 2, sensor 1.
Yep.
Okay, let me zoom in here for you. Now you did it. Oh.
Just want to show some live data. So it's pegged rich on actual signal near 1 volt, and our scan data is showing 20 millivolts.
And
So I just unplug it real quick, see if it changes.
and make sure you got the right wires, okay.
Yeah. Bank 2 sensor 1, right?
Yeah.
How about a lean condition?
Yeah, that was lean.
That was pretty lean.
Go ahead. It didn't respond. Try that again.
So it's rich. Wait, what are we doing here now? It's going up to, look at that. We fixed it.
Oh, no, temporarily.
Oh.
That was a temporary fix.
Man,
You almost had it.
this car is just kicking her ass, man.
Yeah.
Let's see.
Gentle. There she goes.
soft
Boy, that
there.
responded slower than the downstreams did.
Is that a hint? Is that a clue?
Yeah. I don't
So
think
we're just pegged lean here, and there's no response.
so. Okay.
Next, now for the tricky one, right?
Yeah,
The 8.7
yeah.
one.
So the three that were working are seeming to continue to work at the PCM, even though the PCM is displaying the wrong data. So, but the next sensor we got to test is that bank 1 sensor one, which was having that really
Yeah, so
wacky.
I want to see if the voltage, that 5 or 10 volts or negative 10 volts is
Yeah.
coming from the
from
PCM.
the PCM. So I'll shut it off. We'll get repinned out here.
Yep. All right, well, bank 2, sensor 1. Again,
Similar.
wiring integrity checked out fine, so let's write that down. Wiring okay. PCM again,
Yeah,
no response.
PCM didn't-
Same deal.
You know, minutely different scales, but I don't think it's anything.
Yeah,
too-
stuck lean
Yeah.
on the data. All right, let's check the last sensor, bank 1, sensor 1, and that was, if you remember, the one with the really outrageous high voltage reported on scan data.
Right.
But when we measured it, it was
Negative. It was
negative
it was-
6 to negative 10.
Yeah.
So this is going to be the most interesting one.
You know, what's interesting to me is if we do test this and it is receiving the minus, 6 or whatever it is, which I suspect it is, why is the PCM interpreting that as a positive voltage? I don't know. I mean, that's a little beyond me as to why it's taking this weird signal and doing what it's doing with it. Unless it's PCM and this thing is smoked.
So you're saying if it's taking a negative voltage and interpreting it as a high
Yeah.
positive,
Yeah.
large positive voltage and trying to take back the fuel. All right, well, let's back probe this on these pins here and final
Yep.
measurement.
All right, so you're all plugged in, and currently, I unplugged the O2 sensor. So this O2 sensor is unplugged right now because it was forcing our engine so lean. We had to unplug it to keep the thing running. So we're gonna go ahead and keep it unplugged. I'll zoom in on your scope here, and we're gonna see what's going on. We got some weird stuff going on.
All right.
And of course, because we're getting higher voltage, we gotta change our scale and
Uh huh.
all that stuff.
So basically, where?
Let me get the zoomer on here for you.
Where's the button for the? Basically, we just want to display our live data.
So you're
Right
what,
there.
minus 10.
Yeah, we're at minus 10 volts right now.
Sensor's unplugged.
Sensor is unplugged, and on scan data we're showing 1.08 or 1.1 volts. Where is this coming from?
So that's so that's interesting. Sensor's unplugged. Okay, this was the clue. This was the clue. Sensor's unplugged. It's displaying minus 10 volts on the PCM. Just out of curiosity, if you unhook your ground out of the PCM and check it and ground on the battery? Where is this voltage? Is this coming from down the ground side? Is it coming down the positive? You know what I'm saying? Is that?
Okay, so the potential difference between those two wires is minus 10 volts, and the PCM is interpreting that as whatever you're seeing there, 1
Yeah,
volt.
yeah. I don't know why the PCM is interpreting it like that. That's
So yeah, right now we want to see why it's at minus 10. Now let's maybe use our test light and actually force it, ground it out.
okay.
And,
Oh yeah.
Well, what do we expect?
Yeah, because
to see there?
it seems to me that because it's at minus 10, the power's inverted, our power is being fed up into the ground. So
Yeah.
yeah, what if you gave it a
So
ground?
maybe if the test light lights, we'll find if it's
Okay,
feeding
so-
12 volts on the ground.
Okay, so you got a test light.
Yep, connected to battery
Here, let me-
negative, obviously. We'll test
Okay, so,
it.
yeah, because you got your
test light
your-
works.
So your test light's hooked to
This is a ground right now.
battery negative. Yep. And if for some reason that wire has an amperage carrying 10 volts on it or
Yeah,
whatever,
yeah.
this way it won't nuke by sheer putting it right straight to ground.
No, I mean maximum 200 milliamps through
Right,
there, so
yeah.
it's like a fuse basically.
Yeah, basically. So here so you're gonna touch that on the ground.
Yep, just on the ground.
Okay, let
on
me-
the back probe.
Let me zoom in on our data. Okay, so we're at minus 10. Okay, I'm good. So go ahead and touch it, see what happens, if
There you
anything.
go.
Wait a minute.
Yep.
Okay, so you're on it?
I'm on it right now.
No kidding. And look at our scan data. That went to the 0.20. You know what? Let me keep that on there.
Yep.
What's your test light doing? It's not
it's not
lighting.
lit.
Okay,
There's no
it's
current
not.
going
There's no
through it.
current. So you're providing a ground.
Yeah.
Let me plug in the O2 sensor, which has the broken heater wire, which we really don't care about currently. Let's find a connector. This is getting good. Okay, so connector is plugged in, and you're providing it a ground.
Yeah.
Everything stayed the same. You want me to start the car?
Uh,
what if you take away your ground? What do we got?
So it goes to minus
It
10
goes back
again,
to minus 10.
and look at our scan data.
Our
It
scan-
goes up to 1.2 again, so it goes nuts.
Okay, it goes to what seems to be like the maximum value that the OBD data can display. You want to start it and see what?
Well, just pause for a second. Let's think about this. where we
Okay,
wanna go.
yeah, this is a game changer here. All right, so sorry about that. We just had to talk amongst ourselves for a minute in private. I like to call it a little private conversation. So what we're gonna do is essentially what we just did, key on engine off, is we're gonna start it up. We're gonna look at our graph. Ivan is gonna use the test light over there, provide this PCM
With a ground.
and see if we get the same results running. Does this O2 sensor come alive? So let me start it up here. We're probably gonna have to change our scale once we do that. We can look at the live reading anyway.
Yeah.
So, okay.
So it's minus 11.
Okay, and this is O2 sensor plugged in, no heater, and no test light. So you got your test. Yeah, go ahead and change that scale because that did.
So that's live data.
Okay, yeah. Wow, live data is 11. So give it a ground.
Give it a ground.
Live data is at 0.0. Everything's at 0.
Yep. And then our scan data is also showing that we dropped to 0.
Everything's at 0. But we have no heater. This may take a moment to.
This is bank 1 sensor 1, so.
Just for the hell of it, I'm gonna
Well,
take.
it's starting to do something.
Starting to climb.
Are you gonna plug the heater back
Yeah,
in?
let me just twist these wires together. Just go back a bit. So. Okay. Change our scale, so. Okay, there it goes. It's climbing. Okay, so it's starting to heat up. I just twisted the wires on the heater circuit back together, just to help this progress along, hopefully. Yeah, there's our scope.
So you can see the live reading.
You're really screwing things up now.
I'm not a lefty.
Oh, you want me to do it?
I'm pulling the test out.
Oh, okay.
There we go.
There we go. get your connections fixed.
Oh, there it goes. See where Rich. So bring it down.
Is it oscillating now?
Doing something. Oh, look at scan data.
Come on. So bank 1, sensor 1. Bank 1, sensor 1 is there. And up our scope. Look at our fuel trim. Can we see this on the camera? Let me zoom in. So we got a lot going on. I'm excited. So our bank 1, sensor 1 is working. It is oscillating. It has fuel trim control.
Yeah.
And all you're doing is providing it with a ground at the PCM.
Yep.
So if I'm going to make it lean. That worked.
Yeah, look at the trims go up.
Trims go up. Let's see if it starts responding again.
Yep. It should start correcting.
I'll be darned.
We don't need this thing in here.
Yeah, no, let me, so
grab the other one.
bank 1, sensor 1, that's where we're at, right?
Yeah, grab bank 1, sensor 1.
That's what I said, didn't I? Yeah. So that's bank 1, sensor 1.
Why is it stuck at 0.88 when this is not?
Oh yeah, gosh, I've been looking at this so much, I ain't been looking at that. That is interesting. Want to go to the factory data to see what that shows? I don't know.
We're definitely on bank 1, sensor 1, right?
Let me unplug it.
Yeah, unplug it. If in doubt, unplug it test.
That's right, so it's unplugged. And maybe because you're grounding it through your Tesla, you want a real ground, meaning that we know we got no amperage. Let me grab a jump wire. Yeah, I don't know. I'm just guessing.
No, huh?
Let me just give you a ground.
Yeah, permanent ground.
Anything different? I don't know. I just figured. Maybe we know we got no current. It's really doesn't matter.
Bank 1, sensor 2, bank 2, sensor 2.
Yeah, they're all dead.
1, sensor 1. Why is that stuck at 0.88? That's what I want to know.
When we know on our scope, we know our scope is good.
Yeah.
Our oscillating signal here is good.
What if,
Okay, so you just grounded the signal wire, right?
Yeah.
Is that what you're doing? Yeah, so he's touching the signal wire with his test light right there to a ground just to short out the signal wire.
so that, yeah, actual voltage is, it looks like it's in closed loop, it's oscillating, fuel trims. Well, why is the voltage bank 1, sensor 1 not reporting anything realistic? That's my question.
Yeah. You want to look at what we data just for comparison? I mean, we're right here.
Yeah, sure.
I mean, it's easy enough to do. Just for the heck of it. I don't know what the difference would be, but why not look,
Yeah.
Because it's weird. I mean, that's oscillating. I don't know. I guess I shouldn't be surprised it wasn't displaying the wrong voltage correctly. Why would it, I mean, if this, so this is stuck here. Oh no, look. Let me,
Bank 1, sensor 1, huh?
Bank 1, sensor 1. There it is.
Wow.
On factory data.
So wait, factory data is actually
Working. OBD2 data is stuck at 800 millivolts. This matches our graph.
It does. Well, where's our graph?
Gone because I closed it out.
No.
I closed it out. Yeah, look at that, dude. That is, and that's with a permanent ground.
Let's go real quick here. I just want to load up the meter again.
Yeah, well, I think when you close out from OBD2 to OE, it automatically closes your scope.
Really?
Yeah, that might have been my experience.
Anyway, Snap-on, if you're listening, we want to see the scope with the scan data, okay?
Yeah. And we hate going through component tests to find it. That's a ridiculous thing. I wish I could just go to scope, but so So there she is.
Alright, meter.
Dude, this is great. This is a huge turning point. Because this is some proof. Look at this.
Let's go back to our, so we have our scope window now. Let's go to home, reading scanner,
Yep.
and bring up our scope viewer.
Yeah, for that list view.
List view.
Yep, there we go.
Perfect.
Oh man, look at that. Look at that, would you? Looky, looky. So let me zoom in so we can definitely see our factory, our scan tool data. And all we have right now done is provided the O2 with a ground.
Yeah. I'm still wondering what the heck is up with the OBD2 data. Let's do this. Home. So for scanner, let's get out of here. I want to go back to OBD2 direct. Home, OBD direct, OBD diagnose. Start com. So we still have our scope.
Oh, you don't have to dump it to, I didn't know you could trigger back and forth. I thought you had to clear the scope or clear your data. I didn't know that would, I didn't think you could do that.
I think if you dump it, it just closes everything.
Yeah, I thought, I just learned something. Yeah, I've never.
Okay, so we're in OBD2 now, right?
Yeah.
Current data.
I feel like a big dummy now. But you know, how often do you trigger between OBD2 and regular OE data?
Not very often. So I'm really curious here.
Oops, let me get offside. I'm knocking the camera over. There we go. So this is pretty neat.
All right.
And that appears to still be stuck 820.
Custom. We select all. We'll start all the guys and short term, long term. Yeah, that's enough. Let's do. Looking for bank 1, sensor 1, right?
Yep, that's what we're looking at currently. Now it's working.
Sensor 1.
So was that a glitch with the
I don't know what that was.
scan tool? Because there's the real deal.
It's a lot slower.
That's wicked slow.
But it's actually oscillating now. Okay, that's good. I was kind of worried for a second.
So now, I'm just curious. Can you? Okay, so now it won't.
So you have to. Okay, so if you're in OBD2, right, you have to go exit to shut down this scanner. So you stop communication, and then home scanner. And then you can go there.
I had no idea. See, I always hit the car dump button and ditch it. And
No, I think the only time you hit that is when you're done with the card. You want to
okay.
put it in a new bin or something.
Sorry to add that little segment. I needed a quick learning lesson here. I usually don't trigger back and forth between scanners.
So our scope is still going. We want to do from here. So basically, we've confirmed. I'll recap.
Yeah. Here, let me shut this off real quick here.
All right.
And I'm gonna shut the car off. I'm gonna turn this off. Okay, so what we're gonna do, I guess, before we do any kind of big recap or anything here, by providing bank 1, sensor 1 with an external ground on its grounding circuit, it apparently seemed to work. So.
Wait, hold your thought. Yeah, so we want to provide the other ones with an external ground, right?
Yeah. I would say let's try the other upstream. Yeah, try the other upstream O2 sensor. Let's give that one a ground because it's receiving a signal. Let's see if it all of a sudden makes the computer come alive, and I think that is going to.
Do you want to keep the external ground on the first one that we just did and add the next sensor to it and see if they both work at the same time? If we unplug this one, it'll stop working again, and it'll just.
What do you want? You want to just move our leads right to bank 2, sensor 1, and then.
The positive lead I'll move, but the ground I want to provide another external ground.
Oh, okay. So this O2 sensor stays working.
Yeah, we want to.
Okay,
it's
I see.
Now let's keep it working.
Okay, so grab another ground wire.
Okay,
let me grab another ground wire. I see. I'm sorry, I didn't understand. Okay, so here's another ground wire. So hook up another ground wire over here.
Actually, this might be easy with just. So which pin am I going to?
So bank 2 sensor. Okay, so we're probed in the same way. We're on the other upstream O2. We're on bank 2 sensor 1. We left the ground on bank 1 sensor 1, so that one continues to work. Ivan's gonna pull up the data.
So we're just looking at the upstreams right now. And now we have them both provided with an external ground.
Yeah, so essentially, well, the one we know is going to work, but the other one we don't know is the one we just did, the bank 2, if it has the same similar problem condition.
So let's pull up. Let's see here, we can't do short term. Do both short term terms?
Let's just look at the graph right now. Just,
right,
you know, if we're not seeing whatever, then we'll change it, but we're in OEM data right now, just FYI.
All right, and the scope viewer. So we want to focus. We already confirmed that bank 1 sensor 1 works fine with the external ground.
That's correct, and it
Now
appears.
we provided bank 2 sensor 1 with an external ground, and that's on the scope. So let's see how that looks. Does that match our data?
So that's our scope oscillating.
Oh, you look, I even got the scaling right.
Nice. So that's our scope at the PCM with a ground. There's what the scan tool is displaying. I would say we are on to something. We're on to something.
Yeah, we're on the right track. So okay.
So yeah, this is cool. Go ahead and if you want to shut the car off, Ivan, and we'll kind of recap and.
All right. So what did we just see there? We provided the upstreams, the sensor 1s, bank 1s and bank 2, with external ground. So basically what we did was take a jumper from here straight to ground, and same on this side, from here straight to ground, to the battery ground. Okay. What did that do? That immediately, you know, the actual signals on the scope went into good range from 0 to 1 volt, and we did have a little hiccup with the OBD2 communication there.
Yeah, I just assume that's a computer
Then
glitch.
we went back into OEM, and that was showing that the signals, you know, it's reading the signals, it's reporting them accurately. We did a side-by-side scope to scan data comparison.
Yep.
Absolutely confirmed. These sensors are now live. The PCM is happy. It's reporting the right data. And just because we provided a external ground to this ground wire.
Yep, and based on our wiring diagram here, that should already be a solid earth ground, right? I mean, that should be, according to this symbol, that should be a ground, a testable ground.
Yeah, so the only conclusion we can draw from there is this is not a good ground, and neither is this, and probably neither are these two.
And that's an assumption. We
That's an
did not
assumption,
test. We did not test those, but the two that we did.
What's the easiest way to check for a ground?
If it was me,
and
I was going to test that, I'd just unplug the connector and grab my test light, and because there's no reason we can't use that, hook the test light to positive, touch this pin in the PCM.
Okay, so we already have a back probe, so we just touch test light, hook to battery positive, right?
Unplug the sensor and
test light,
and it should light.
It should light if we, you know, back probe this connector.
Assuming this is all right.
Yeah.
You know,
sure.
I mean, it should.
So it should light up. So let's do that to all 4 oxygen sensor grounds and see, you know, if we're actually missing them.
Yeah, it's the easiest thing to do, and yeah, like you say, by providing it with one, that's what the test results say. So it's starting to look like we might have an answer here.
Okay, so now our next test is going to be just to verify if we do have grounds at the oxygen sensor signal wires at the computer, like it's showing here. Because when we provided an external ground, the sensor came to life, so that's probably what we're missing, but we're going to verify this with a test light hooked to battery positive, and now when we back probe and touch it on that terminal, it should light, since, you know, even though it's a sensor ground, it should still light a test light.
Yeah, because according to the diagram, that is an earth ground, and what we've discovered, it is also, you know, it's a ground straight to battery, because we, you know there's no current flowing up, there's no kind of bias voltage signal. So, yep, okay.
Now, I mean, obviously we could get your ohm meter out and check for continuity between here and the battery, but the test light at least provides some kind of load. And I found that is key in some situations where, you know, you might have a really weak ground, your ohm meter will show close to 0 ohms. When you put a test light on it, it doesn't light. That's not a ground.
Yeah, you can run one strand of, you know.
Yeah.
50 gauge wire to your starter and have perfect continuity, but it's not going to start the car.
Exactly. So let's do it. Here's well, we'll just go in all in a row. You already have them all back probed, so let's go down the line.
All right, did you already test your test light? Okay,
Hey,
there you go.
Cummy.
Yeah, that's a common rookie mistake.
Huh? I'm still learning here.
Yeah,
Come on,
that's a scope on a rope, dude. That's a very
scope on a rope.
technical.
Well, I'll just touch it here just to make sure. I'm not seeing anything on any
And you
of
got
the
good
wires.
probage.
Yeah, I'm touching the metal inside. I can touch the metal out here.
I'll be darned. So,
I think that's what we're missing. I mean, that,
well, yeah,
that's what
yeah.
confirms our other test. This is what we expected here.
so we have no ground there. What if we check? I guess the next thing. So where does the PCM get this ground from? We don't know because it doesn't show us the internal workings of the PCM. But I would assume, and this is just an assumption, that it has to get its ground from external source. The other ground wires going into the PCM.
Yeah, main powers, main grounds. Now, take a step, look at the big picture. All our other sensors are working fine.
Right.
You know, all the other data is showing as it should.
Yeah.
We have no other drivability complaints really. You know, if there was a main power issue or ground issue, the car
you would think, but
you would have some kind of symptom. So we expect the grounds to be good here. The only, I mean, we'll check them right now. But the 4 oxygen sensor grounds, they're not there. We just proved that they're not grounded.
and then we proved if we make them work, the computer works. Everybody's happy.
Yeah. If we provide them with a ground, then everything's happy. So let's.
You want to check
Yeah, basically what I want to do
PCM
now.
grounds.
Yeah, so let's put a clip on the.
And I think another thing to mention too. So we're going to check PCM grounds going in. It's a plastic PCM. We don't have to worry about any kind of case ground or getting a case.
So this is my positive
Yep.
test terminal. Once it finds the ground, it'll light up.
Diagram here. Okay, so you've got
Which pins are we checking here?
B19. You've got 7, 4, and 7 on B19.
All right.
So you got ground. Oh, let me get the camera. So let's see. You got that on the camera. Where's that?
All right.
So you got ground there.
So that's pin 4.
Another black. Also the 2 black wires.
7. Yep.
So our
Confirmed,
ground
that's fine.
is. Yep. And then you've got B20. Looks like all black wires.
All fat black wires. I see 4
yeah,
of them.
okay, yeah. So yeah, it's obvious at this point.
1, 2, 3, and last one here. 4.
Yep. So that confirms we have grounds that have the ability to carry current.
Absolutely, yeah. At least 200 milliamps.
Yeah.
So, and once again, we'll just double check here. No ground there. Nothing there. I mean, there's no ground in these oxygen sensor
be done.
signal circuits.
That's okay. Well, let's conclude. Okay, so we've come back over to the whiteboard of knowledge, and let's conclude with our findings.
Let's do it. So, our findings. Confirmed, we do not have grounds at the computer on our oxygen sensor signal circuit.
Correct. Yeah.
How do we explain when we actually measured the signal with our scope? You know, we back probe here and here, we got a good signal from the sensor all the way to the computer. Why is the computer not seeing that signal?
Well, what if we look at it in like a really simple, really simple way? We have our computer, we have our Veris. It's a sensing circuit. It's our voltmeter.
Okay.
And what if we don't look at this as a PCM, but we look at this as a sensing circuit, as another Veris? We're looking at
what it is.
Yeah, we've got our 2 probes going in. This thing has its 2 probes going in. Our screen displays what it sees.
Yeah.
This screen displays what it sees. So let's look at it in that sense.
So the oxygen sensor, first, the oxygen sensor, what does it do? It provides its own voltage, 0 to 1 volt. So let's just draw that as a battery, okay?
Okay.
That gives out 1 volt. So
Let me zoom in on this so you can see. So I think this is a really
here's a battery. positive, negative. And this is 0 to 1 volt, so 1 volt max. That's our O2 sensor.
Okay.
So O2. Now, well, like we did to begin with, we unplugged the sensor, right? So the PCM's not even in the picture. So we just have our 2 wires. We connect our Veris, or scope or voltmeter between here and here.
Correct.
And that's like a bench test on the car.
Yep.
We got good readings, 0 to 1 volts as we expected.
Yep.
No issues there. The oxygen sensor is fine. Now, here on this side we have our PCM.
Yeah. And this is our Veris.
All right. So this, as it's drawn in the diagram, it basically has. Can we see that? Yeah, a couple of resistors there, and then the other side is just a plain ground. So this is the sensing circuit. You can see that resistor is grounded, so it's actually probably a voltage divider. But anyways, it's also a voltmeter. Pretend this is a voltmeter between here and here.
Right. Yeah.
Internal, in the PCM, right?
Yeah.
And then the computer reads that and then throws it up on the scan data.
Spits out on the screen, just like the Veris does. It reads it, spits it up on the screen. Yeah.
So let's draw that in. So there's a voltmeter here. And that goes to scan data.
Yeah. Or the screen, I guess either way. Yeah.
Mm-hmm.
So.
Mm-hmm.
Yep. And then you're going to take those wires.
Yep.
Right.
So. How do we want to draw this? Maybe there's a connection there. Okay. So at the computer, we did the voltage check again. We actually back probed directly at the computer at this connector, and we saw that the voltage is the same. So this wiring checks out. This is good. This is good.
Yeah, wiring's perfect.
It's perfect. But our scan data still didn't agree with our voltage, actual voltage. So, that's what could be the problem. Why would this not agree?
Because this voltmeter, if this is your ground.
So it's connected, right? Oh,
yeah.
There's.
Yeah, there's. That's why the wires. This is no different than taking your Veris. Going like that.
Pretty much.
And
what? Maybe it's a bad connection right here, right? Little cruddies in here. Yeah. But all four. That's a coincidence. We check the pins and they're really small, but they make contact.
Yeah, they make contact.
And so the only explanation here is bad circuit inside the computer, just in this ground circuit, just for the oxygen sensors.
Yeah, because the signal side is not busted in there because once we grounded it received it.
So what we did is, so what did we do to prove this concept?
Well, we'd have to draw a battery or another external ground.
So this is our battery.
Our actual car battery or chassis ground.
So let's draw it down here.
Yep.
This is our 12 volt main battery, right?
Yeah, so we ran a wire from that.
So that goes to the PCM, powers and grounds, which we check the grounds at the PCM, that's fine. How does this all work? So basically what we did was, let's see, we provided a ground externally from here, right?
Yep, correct.
To
negative.
Let's go over here, right to battery ground. Scan data picked up, started showing correctly, right?
Yeah, because we made a complete circuit.
We made a complete circuit, so basically we fixed this voltmeter inside here.
Yeah.
Right?
Yeah, essentially, yeah.
So you can see that the negative now is, how do we want to draw this? Like that? Is that correct? So the whole PCM is grounded, but this pin And these 4 pins, they have a break. Is this making sense?
Just looking
Do you
here.
agree with this connection? Like this is a main PCM ground, which we checked is good. And is that connected
Okay,
inside?
sure. I
Because
see what you're
if it
saying,
wasn't, our scan data would still not
Yeah,
show
that's
anything.
right, yeah. So, yeah, because we checked all the main PCM grounds, that's right, so, yeah, you're correct.
Okay,
Okay,
so let's give this a little more thought and
Yeah,
continue in a little
Yeah.
while.
we had to have another little private meeting.
Yeah,
We just wanted to make sure that we're gonna be able to explain this in the best way possible.
because it seems to be really simple, right?
Yeah,
But once you really try to wrap your head around it, you can totally easily get sidetracked. And anyways,
so yeah, let's try to explain
Let's-
this in the best way that we think we know how to, or that we have observed, and so anyhow.
all right, so think of the PCM as a voltmeter, okay? And our external voltmeter, that's our scope, that's, you know, what we connected externally. Now, basically we have 2 batteries here. One's the oxygen sensor, the other one's the main battery. So you really have to be careful where your grounds are.
Yep,
You would think that grounds, everything, you know, if a ground's a ground's a ground, they're all connected, right?
That's
But what if they're not? Could you get thrown off, you know?
because that's producing its own voltage,
Yeah,
so that's,
this is
Yeah.
producing its own voltage, so if we measure across those 2 wires, yeah, we'll read the voltage of that oxygen sensor, fine. But how does this voltmeter work? Since we're supposed to, you know, on the diagram it says we're supposed to have a ground here. And that would be, you know, sensor ground is ultimately connected to battery ground, right?
yeah, all the grounds should lead together.
All ground's a ground, right?
Yep.
It should be. So the voltmeter in here, it's, you know, I think it's fine. The signal is the positive. That's fine, it's up and connected. And the negative lead, you think of it as a lead, right? Positive lead, negative lead. That's connected to a common ground, which is the battery ground,
Yep.
which is supposed to be also the oxygen sensor ground. They're supposed to be tied together.
Yeah,
But-
internally here, this goes to here to here to here,
Yeah,
here to all these
mhm.
other sensor grounds. Yeah.
Absolutely. So can we explain our voltmeter reading if we have this problem, which we just confirmed with our test light, that this is basically a floating wire. There is no ground here.
Yeah. So essentially, it's like if we took that O2 sensor wire, we cut it, it's just non-existent.
Yeah,
So-
exactly. What would that voltmeter read?
Well, I think the easiest way to do that is, so we've got our Varus, we've got that hooked to the positive.
Yeah.
If you take and did this, now run your wire down to your negative on the battery.
Okay.
Yep.
Okay, so across this one.
Yep, across
Across
that
this
one.
one.
And to that, I believe the Varus would display the same voltage that it was on our PCM.
Scan data. Which is
Because we essentially have no ground. Because these are 2 separate batteries, if you look at it in that sense.
wow.
So,
I don't
yeah,
know if we want to do that experiment to back ourselves up, or I mean, it's pretty quick. It's one voltage measurement.
might as well, we're into it this far. I think that'll be definitive. And by grounding this, now we've made the common through everything.
And yeah, exactly. Like I said, we provide an external ground to the sensor.
Like it should have been done internally.
Like it should have been done in here, and it wasn't. For some reason, we still have to have some theories on that. Well, at this point, it's looking like a bad computer. I mean,
Yeah, I
all
would
the
have
ground
to,
should
yeah.
be common.
Oh yeah, absolutely. It's,
I don't. We know the pins are good, the connections are good. I don't really see another
we just have no
explanation
internal
of
grounds.
this.
I mean, essentially, we could take these 4 oxygen sensors, we could cut all 4 wires,
Yeah.
twist them
Twist them
together,
together, put it the battery ground.
put it to battery ground, and this car
it'll all
should be
work.
this car should be.
And I think just to prove of concept, we'll do that with the back probes and tie them
Yeah,
all
you still got a
together.
probe, so yeah, so we could do that, and yeah, just for proof of concept, we are missing the internal ground of the PCM.
So this is our problem on all 4 sensors. Again,
That's bizarre.
yeah, with some
Well,
high
see,
current
on a
and-
diagram, I always take diagrams with a grain of salt. I never trust them ever.
Mm-hmm.
But this to me, these look all individual. Comes in, individual, individual. It's
Mm-hmm.
But I don't know if, you know, inside the PCM, you know, where the grounds come in, you know, there's 4 of them. Is there a big, you know, is there a bus bar that hooks to them that goes, you know,
Yeah, and then there's
here?
a break in that bus bar, and then that would account for all 4 of them.
That I don't know. I'm not a...
So short of tearing the PCM apart, I think at this point,
you just do proof of concept, hook them together.
We're suspecting a bad ground internal to the PCM for the oxygen sensors.
Well, that's definitive. I mean, that's,
so
that's 100%. Put a test site on it. They're not there. We provide them. It works.
Yeah. I don't see any other.
Yeah. I mean, just real quick before we end the video, I say, like I say, jump run, start it up.
Okay.
You know.
So as is, without making them work, just connect the scope up across.
Oh, okay, yeah, we can do that real quick. We can make sure that, to prove our theory.
Oh, okay.
Yeah, hook our scope up here and hook it to battery, you know, battery ground, and it should display whatever scan data is, or some kind of wacky nonsense. It shouldn't display as the O2 voltage by any means, so, because the 4-wire O2 should not ground through the housing, right?
Yeah,
the only
old ones, yeah.
The old single wire would ground through the housing. These 4 wires have an independent ground wire.
Yeah. So for better signal to noise ratio, probably.
Yeah.
I mean, it's the same concept. You could ground the battery directly instead of going through the computer, but it's all the same ground.
Right. Yeah.
But if you cut that wire, then you have a problem. Then the voltmeter
can't sense it.
It's basically like, you know, unhooking.
Well, it's sensing it. It's sensing this, which is nonsense because, you know, there's nothing there. It's just there's no loop, no loop-de-loop.
No current loop, no voltage drop.
Yeah.
Right?
So, yeah, let's do that test, and then I'm pretty sure we're just going to call it and say, this baby needs a box.
Cool. All right.
Okay, so we had our back probes still in there. All we did is just put some jumper wires on them.
These two, right to battery negative.
Yeah, right to battery negative. We plugged in our scan data, our scan tool, and we're displaying all 4 oxygen sensors, which theoretically now should all start working. Because we've provided them all with a external ground. So what all we got? We got a min-max.
Big 1 sensor, big 2 sensor ones, right? These are upstream.
Okay.
These are downstream.
Okay.
Here, unplug like one of them. So make sure it's the right one.
Okay, so this is bank 1 sensor 1 getting unplugged. Bank 1 sensor 1 is unplugged and it's flatline.
This guy right here.
Yep.
All right. Yeah, but that's the right one.
So that's the right one. I'm going to plug it back in.
Then big 2 sensor one, I guess.
Bank 2 sensor 1 is unplugged and it's flatline. Okay. So it's going to take a minute for the fuel trim to
This was our fuel trim, make sure everything's happy.
It's going to take a minute to stabilize. We pop her up on a faster idle because I see it appears that our Catalytic converter is not really doing so hot.
Keep in mind, it's been running an open loop for a year, and it might have,
Yeah, this is going to be expensive a little bit.
it might have cooked it.
Catalytic converter.
And look at the short term countering the long term exactly. That's nuts. Looking at scan data, it looks like we don't have any cats at all. They're the same. They're all. So, if this guy wants to pass emissions, this may not happen after we get done with the car, right?
Wow, no, I mean, obviously the Catalytic converter is smoked too.
That's unfortunate.
That is unfortunate. Because, you know, he brought it in with the engine light on. If we tell him that he needs a computer, and he thinks it's going to fix it, and essentially it does, but if the car's broken beyond that.
And the checking this light's still on, he won't believe that he fixed it.
Right, yeah.
Oh, okay.
Because it's still coming up with these oxygen sensor problems.
Oh, man. So, in this case, we have to warn the customer, we're dealing with your no activity codes.
Right.
Your cat still might be shot once you get the oxygen sensor.
I think it's pretty definitive, because we're running about 2,000 RPMs. I mean, them cats should be heated up by now.
Yeah,
They're oscillating pretty good. Wow. kind of.
You told him you could fix it, right?
I told him I could fix it. Without a doubt.
Without a doubt, man. Well, at least we proved the concept. Look at the fuel trains. They're beautiful. They're running at zero. Yeah. Everything's working fine. So,
let me kick it back off of fast idle. Oh, that sucks about the converters. Almost have to, you have to bring that up. They don't work at all.
You don't put in salty followers here?
Give
$5 fix?
Give me some $5 and followers.
Or is there a fine associated with
a couple emulators. Give me some emulators.
Emulators?
Yeah,
okay.
plug in some emulators. So, do you want to just real quick do our, hey, look at that converter starting to kind of work a little. It's a man inverter, and it's probably at $1,200.
Yeah, idle, but with any flow in it.
Yeah, any flow, yeah.
It doesn't.
Should we just do our proof of concept real quick? Just probe one of the sensors independent of the ground and just make sure that it displays the same data real quick?
Sure. Yeah, let me get some testing.
All right, so just our last test, just our proof of concept. We're back probed into bank 2 sensor 1.
So we removed the external grounds. So we're back to the original condition of the car.
Just in the signal wire.
The only thing we changed now is our ground is on the battery instead of the oxygen sensor ground, which is we don't have now.
Yeah. So our meter is hooked up like the car's meter.
Yeah.
So we should see very similar results. So I'm going to start it.
Well, I'm guessing we won't see much.
No, it shouldn't. Just a bunch of
noise.
Let me get over here where I can display this. Okay. Try to zoom in.
It'll be interesting. Let's try bank 1 sensor because that was like a weird one.
Oh, okay.
And that was.
Well, before we change with the one that was reading wacky here, we'll just kind of show you just even proof of concept on this one is correct.
It's dead on the money. 140 millivolts there. It's reading 117.
Yeah.
We didn't expect to see anything at all. So let's go to...
Car's running like crap.
Yeah, it's trying to compensate for something. So let's grab bank 1 sensor 1, right?
Yeah, so that's one.
One sensor 1.
I doubt on it. So this is the one initially was going haywire.
Bigger. So 5 volts, and let's change our voltage scale on here.
Well, I remember this is going to be different because it's only displaying 5, but it was actually, it was getting some weird,
that's true.
wacky, so
yeah, we can't trust this.
yeah, we can't trust it because it can only interpret so much voltage. Evidently. 5 volts on OE and 1.25 on generic.
Without the scale, there's one scale. 1 volt. There it is.
Yeah.
So we're on 11 volts.
Yeah.
Okay.
So yeah, I mean that's proof of concept. That shows it. There's the problem.
So bad computer, right?
Yeah, that's what you are.
The grounds aren't connected.
Already installed. So I guess it's got to be a box. Right? We've got good ground supplied to it.
Yep.
We've got, what, six ground wires we checked that go
Yeah,
to the
the common
PCM.
grounds are good.
Our common grounds are good, and we're missing the grounds internally in the PCM, so maybe I'll grab myself a roll of solder and I'll do some fancy soldering inside of it and run me some new lines.
Yeah, we say everything else works. Cheap fix is just to connect all the grounds together.
Yeah, cut the wires, hook them together. I mean, it works, but I think the real fix is buy a box. But there's an underlying condition. You know, when we do that, we buy a box, put it in. We got a PO420 and a PO430 that are going to come right up. I mean, it's obvious.
Yeah, it's kind of a hard situation to explain to the customer, right?
Yeah, and the weird thing, and the other thing is too. So yeah, we're going to get a PO420, PO430. How many evap codes are we going to get? How many? You know, what else? This thing probably hasn't run a drive cycle.
Yeah, in more than a year.
In a year, you know, money light's been on for a year.
And you saw how poorly it was running.
Oh, yeah.
If it was running like that, you probably cooked the cats or something. If it was dumping raw fuel, just trying to compensate.
Yeah, because all those O2 sensors were reading like what 0 volts or 0.2. So the fuel trim's pegged out
on one bank.
Fuel trim's pegged out on one bank. Bank 1 and 4 is.
What a mess. I mean,
Yeah, so that sucks because here we have to buy the carb certified converters. We gotta,
Oh man,
New York State.
and that's
so.
like twice as much as.
Well, on this thing you're
other-
probably buying OEM. I doubt any aftermarket makes
And
it.
Mitsubishi OEM. I mean,
Makes a man inverter, you know. So
yeah, at least $1,000 right there.
what are you gonna do? Oh, that's probably way more than $1,000.
More than the car's worth.
Yeah. So what do you do? So this is a hard one to reiterate to a customer. Hey, you need a computer. He thinks great, it's gonna fix it, but then I have to tell him, oh, you need a computer, but your light's gonna come back on.
Yeah.
You know, how do you explain
But
that one
just
away?
tell them to watch the video or something, yeah.
Yeah,
So we
yeah,
can show it
watch
everything.
the video. Yeah, 3 hours later, with the rest of you guys, he's passed out cold with a half a bowl of popcorn.
Yeah, right.
So this is a very long video. I think we did a good job diagnosing it, and I'm willing to call the box. And
Yeah, I'd say the cheap fix, maybe wire it up, you know, give it the grounds,
yeah,
run it and see what codes it sets
Yeah, run a drive cycle.
before throwing,
Doing
you know,
anything.
doing
Yeah.
anything to it.
yeah.
You
And
know.
just tell them, hey, look, I can fix it. Did a temporary, you know, rig up job, and here's what's going to happen if we fix it.
Exactly.
If we
Prove the concept.
yeah, if we fix it the right way, here's the problem.
Mm-hmm.
Here's what's going to happen,
Yep.
and move on from there.
Exactly.
So
That's where we're
I
at.
guess that's it. So
Alright.
we'll wrap it up. So thanks for watching.
And if we have anything new to add to this, maybe a little short part 2.
Well, what I'm going to do, I'm going to talk to him.
See what the
If
customer wants to do.
he wants to go for it, we're going to bring back part 2, and
Okay.
we're going to get the parts. We're going to fix it. You know, we'll get out our Haynes manual and we'll put a catalytic converter on it, and
Plug and play, man.
yeah. So anyhow, I guess one to hear. So thanks for watching. If you like this video, give us a thumbs up. Don't forget to check us out on Facebook. I'll keep you posted with Ivan's status if he ever gets a YouTube channel of his own, and his website. He's got a lot of stuff he needs to get done because people want to know about
Yeah,
it.
so busy making videos with Eric now. I don't know if I'll ever get around to.
Hope he
do
doesn't.
my
Hope
own
he doesn't
thing.
get divorced
I
over
haven't-
this.
Yeah, I know, man. So yeah, we'll keep you up to date and
Yep. And remember, viewers, if we can do it, you can do it.
yeah.
So thanks for watching.
Later.